And welcome back, and it is the 17th of May, Further Maths, and let's just go straight to the first question. Right, and we start with a combinations question. Now, remember yesterday was quite difficult, so let's see how this one goes. So how many, I'm going to highlight it again, how many 6 digits, in fact, actually I'm going to even start by going 1, 2, 3, 4, 5, 6. How many 6-digit even numbers, great, less than 700,000 can be made using the following digits? Now, the key to this question, the problem with this question is these even numbers are not effectively the same as that even number, because the first two give me a number less than 700,000. In other words, I can use them in the first digits, and the last one I can't. So I'm going to have to do this twice. So 1, 2, 3, 4, 5, 6. I'm going to do it once where 8 is my last number, because that means for my first number I can use 1, 2, 3, 4. I can use any one of these 4 digits here. So therefore I've got a choice of 4. Now let's imagine, for the sake of argument, I've used the 8 because actually that was a given. I've used, in fact, actually I'm not being consistent now. That's 4 choices and that's 1 choice. And that is an 8, so let's get rid of that 4, otherwise you can't see what I'm doing. So let's imagine I've used a 1. It doesn't matter whether it's 1, 2, 4 or 6. That leaves 4 numbers behind to choose from, 3 numbers to choose from, 2 numbers to choose from, 1 number to choose from. Multiply all these together and I get 4 times 4 is 16, times 3 is 48, times 2 is 96, and that is 96 numbers there. Okay, so far. Then the next option, so you'll remember I forced myself to choose the 8. I could also choose as the last number 2, 4 or 6. So there's 3 choices there. However, now when choosing the first number, I can't choose either the 2 or the 4 or the 6. In other words, I have 1, 2, 3, 4 choices minus 1, which is 3 choices. And now for the next number, and again, let's do an example. So let's pretend I've picked, what have I picked? So I've picked 2 and 1. That leaves behind 1, 2, 3, 4 numbers here, 3 numbers here, 2 numbers here, or 1 number here. So again, calculator out. And that gives me 216, which makes sense because the last digit has more combinations. Add these together, so 216 plus 96, well, it's 316 minus 4, which is going to give me 312 combinations. Good question, that. Next question, looks like we've got a third question. Okay, it's quite clever. I know where this is going. This is another one that you need to make sure you've tried if you haven't, and rather than just watch me do it, because the trick to this is the thing you're going to miss in the exam. So let's do the arguably easier bit. So root 27, and actually what I'll do is I'll do them over here and then do it underneath. So root 300, start here, is the same as root 100 times root 3, which is 10 root 3. So this is my clue that everything's going to be in root 3. Root 27 is the same as, well, you might just know this one, but it's 9 times 3, so therefore this is the same as 3 root 3. And root 108, you may not know 108, but root 108 is the same as 36 times 3, so therefore root 108 equals 6 times 3, because it's root 36 times 3. Now, if you didn't know that, then again, I think, well, actually, we can do it the way around. We don't need to do prime factors, do we? We know there's going to be a 3 in there because we know it's 108, so you divide 108 by 3, and you do get 36. So actually, I'm using my knowledge of the fact I'm going to have a root 3 or a 3 in there somewhere. Point is, I've now worked out that this is equal to 10 root 3. This is equal to 3 root 3, and I'm adding. This I do not know, and this is equal to 6 root 3. So I've got 10 things plus 3 things, that's 13. Take away 6 gives me 7, so this is equal to 7 root 3. But that's not my answer, because the 7 is on the outside. So therefore, what I'll do, put this over here, is I can say root y is equal to 7 root 3. 7 is the same as root 49 root 3. And then I put the 49 inside, so that's going to give me 147. Yeah, the square root of 147. So that's going to give me the square root of 147. So I'm basically using surds backwards. It's a cleverly worded question. Next question. The circle C has equation, gives me an equation. Find where C crosses the y-axis. Well, this one's not too bad, is it? So if it crosses the y-axis, that means that x is equal to 0. So in other words, I'm just going to put 0 into this equation. So I've got 0 minus 3 squared plus y that I don't know plus 4 squared is equal to 25. Let's expand. So 9 plus y squared plus 8y plus 16 equals 25. Let's go over here. Collect on the left-hand side. So y squared plus 8y. Now 9 plus 16 is 25. 25 is on the other side. That cancels out. That gives me 0. So they made this a little bit easier for us, haven't they? So therefore, factorise this. It gives me y plus 8 equals 0. Pretty straightforward now. So therefore, y equals 0 or y equals minus 8. And I think that'll probably be okay because it doesn't say coordinates. But if it did say coordinates, of course, it's going to be 0, 0, goes to the origin, or 0, minus 8. And that is question done. Next question. Index rules. I like index rules. Now, because this is a further maths thing, I'm just basically going to go for it because I think people that watch this video are going to be pretty good at doing this stuff. So I know 32 is 2 to the power of 5, and I can expand the bracket straight away, so that's going to be 5x minus 100. I know that 8 is 2 cubed, so that's going to be 2 to the 3x, and I know that 16 is 2 to the power of 4. I'm solving, so I basically want to find out what x is. So dealing with the left-hand side, that's going to give me 2 to the 5x minus 100 minus 3x is equal to 2 to the 4. So in other words, 5x minus 3x is 2x, minus 100 is equal to 4, which means that 2x is equal to 104. Not the best number in the world, but x is equal to 52. That's it, question done. Nice and easy, that one. Next one. A straight line L2 is perpendicular. Again, I'm going to get my highlighter out. So perpendicular to the tangent, right? So in other words, the normal of this here at this point. L passes through. Okay, so basically it's find the gradient, find the point. So let's start by finding the, what do I want to do? So tangent at the point x equals 1. So I need the gradient of the tangent, don't I? So dy dx is equal to 2x plus 1. That's okay. And then x equals minus 1 means the gradient of the tangent, mt, is equal to 2 times minus 1, which is minus 2, plus 1, which is minus 1. Which means the gradient of the normal is equal to 1 over minus 1, or minus 1 over minus 1, which is equal to 1. Which means I just need the equation of the line y equals x plus c that goes through minus 8 minus 3. This one's not too bad, is it? So minus 3 is equal to minus 8 plus c, which means that c, well, minus 3 plus 8 is 5, which means c equals 5. So therefore, the equation of my normal is y equals x plus 5. And that is today done. Again, not too bad, nice mix. I really like that third question. The third question is quite easy to get wrong. Always love index rules. Let me know how you found them. I will talk to you tomorrow. Thanks all.